Hi, Math 2 Enhanced. In this lesson, we're going to work on rewriting exponential form, which is a form that you worked with last year in Algebra 1, into logarithmic form, and vice versa, back again, and also evaluating a logarithm. So a logarithm is an exponent. So the answer to a logarithm is always your exponent. So let's take a look at an exponential equation. This 3 to the 4th equals 81. So let's write this up here. 3 to the 4th equals 81. 3 is my base, 4 is my exponent. And when I raise 3 to the 4th power, I do get 81. Let's say I want to rewrite this in this new logarithmic form I'm supposed to be learning. So there's this really handy backward C. Oh, I changed it into a highlighter for somehow. Backwards C. So I'm going to draw, starting with my base, I'm going to draw a backward C. The first thing I encounter was my base of 3. The second thing I encounter was my answer of 81. And the third thing I encounter is my exponent of 4. I'm going to write my logarithm in that same 1, 2, 3 order. So let's start it. My log base 3. So I'm going to write a little subscript 3. That was my first number in my backward C. It's the first number I write in my logarithm of 81. That's the second number in my backward C. So I'm going to write that second equals my exponent of 4. That was the third number in my backward C, and it's the number I write third. This is my logarithmic form, where my 3 is still my base. That's the base of 3. 81 is still the answer, and 4 is the exponent. Because remember, a logarithm is simply an exponent. So let's jump over here to the other side and take a look at a log equation that's already written out. So let's rewrite it up here. Log base 5, little subscript 5, of 25 equals 3. So if I was going to read this, I would say log base 5 of 25 equals 3. So I'm going to use my backward C again. Again, I'm going to start at my base, go all the way over doing my backward C. I encounter my base first, my 3 second, and finally my 125. So if I want to write my logarithm in exponential form, I'm going to start with my first part of my backward C, which was my base of 5. The second thing I encounter is my exponent of 3, and that equals the answer of 125. Again, the 5 was my base in both equations. The 3 was my exponent in both equations, and the 25 was my answer. And then this is how I would convert back and forth. Let's look at some additional examples of that. So in numbers 1, 2, and 3, we're given an exponential equation, and we want to rewrite it in this new logarithmic form. It'll be log base b of some number equals my answer. So let's begin here. Let's draw my backward C. The first thing I encounter is the 2, so I write my log base 2 of, the second number is my 64, equals, the third number I encounter is my exponent of 6. And remember, a logarithm is equal to the exponent. It makes sense that this logarithm is equal to the 6. Now, we've worked with negative exponents. Negative exponents doesn't make anything negative. It makes my number go to the denominator in this case. And so it's 1 over 4 squared, which is 1 over 16. So this exponential equation makes perfect sense. And now I'm going to rewrite it as a logarithm. So let's do my backward C. I encounter my base of 4 first. So log base 4 of 1 over 16, that's my answer, equals my exponent, that's my negative 2. Finally, let's look at this next one. I think they should have the 1/3 in parentheses, by the way. So let's think about what this is saying. 1/3 cubed is 1/3 times 1/3 times 1/3. Oh, yeah. That would equal 1/27. That makes perfect sense in my mind. So I would like to rewrite this as a logarithm. So let's do our backward C. I'm going to start at my base. So log base 1/3. The 1/3 is my base of 1/27 equals, I end up at my exponent, which is 3. Again, my 1/3 was always my base. In both equations, my 1/3 is my base. In both equations, the 3 is my exponent. And in both equations, the 1/27 is my answer. So let's take a look at a logarithmic equation that we want to convert back into exponential form. So I'm going to do this much the same way. I'm going to do my backward C starting at my base. My backward C goes all the way over to my 2 and finishes at my 49. So in exponential form, I have my base 7 to my exponent of 2 equals 49. And I do know that's true. So now let's take a look at number 5. I'm going to do my backward C, go all the way around, doing a backward C for all 3 of your numbers. I have my base of 2 to the exponent of -4 equals 1/16. And I know that's true. The -4 would make it go to the denominator, and 2 to the 4th power is 2 times 2 times 2 times 2, or 16. So just looking at that makes a lot of sense to me, more sense than maybe the logarithm. So now let's take a look at number 6. So let's do our backward C, and I get 8 to the x equals 48. In this problem, I would need to find x, and that's something we're going to be learning how to do in future lessons. But this is me converting it to exponential form. So let's jump down here. Sometimes we use logs to evaluate, to find answers. When we do this, we need to be able to do this without a calculator. We'll probably have a non-calculator quiz on evaluating logarithms. You need to know how to find this answer without using your calculator. So how do we do this? So it says to evaluate each logarithm. In other words, you and I are going to find an exponent. The exponent is my answer. A logarithm is always equal to an exponent. So when I have logs like this, I'm going to set them equal to x. It's going to help me use my backward C to rewrite them in exponential form. Because once I rewrite them in exponential form, I can mentally figure them out. And remember, I have to be able to do these without a calculator for one of our quizzes, so I want to make sure I can do this. So let's rewrite. We're going to rewrite in exponential form to help me mentally evaluate these. So let's do our backward C, and I get 5 to the x equals 625. So now I need to think of this answer. You could always grab out your calculator, and you could do 5 times 5 times 5 and times 5 to see if you eventually get to 625. And you do. It's 5 times itself 4 times. So I know the answer to this problem because 5 to the 4th power equals 625. Sorry, I just wrote on those letters. So in this problem, x equals 4 is my answer. So this logarithm is equal to 4. Let me slide my page up. It's a little bit, so I have a tiny bit more room, and I won't be writing the letters. Sorry about that. So my answer is 4. The log base 5 of 625 is equal to 4. 4 is my answer. So sometimes I have logarithms that have what I consider odd. They're an odd logarithm, like there's something extra to think about. And number 8 and 9 are examples of that. So let's first put them in exponential form so I can show you what I mean. In this first one, when I use my backward C, I get 8 to the x equals 2. Anytime your base is equal to something smaller, it's good to look for a rational exponent. In other words, something you're doing a square root or a cubed root or even a fourth root. Something that's going to make that base actually a smaller number. So in other words, I want my 8, I want to raise it to some power where I get a 2. So my 8's got to get smaller. I don't know if any of you guys are thinking about our last unit, but for example, I'm thinking about how the cubed root of 8 was 2. So it makes sense that 8 to the 1/3 power is 2. The cubed root of 8 is 2. It looks like my answer for x is 1/3. X equals 1/3 is my answer. And my logarithm, base 8 of 2, is equal to 1/3. 1/3 is my answer. The answer is an exponent. A logarithm is an exponent. So let's take a look at another one that involves me thinking a little bit extra. In this problem, when I do my backwards C, I get 3 to the x equals 1/9. So when my base is equal to a fraction, and my base isn't a fraction, sometimes I need to think about maybe a negative exponent. That's what's going on in this case. In this case, I have a base of 3, and I want to raise it to some power to get 1/9. So in my head, I'm thinking about the fact that 1/9 is 3 squared. So if I take 3 to the negative 2, that's really 1/3 to the positive 2, which would be 1/9. So it looks like I need to square the 3 to get 9, and I need to make it a negative 2 to get 1/9. So x equals negative 2 is the answer. And I know that because the log, base 3 of 1/9, is equal to negative 2. So let's take a look at some additional examples. So if you have the packet from class, you have a blank page at this point. So let's look at some of these different cases. So first of all, let's write down 4 examples. My first example, example 1, log base 2 of 8 equals x. Example 2, log base 8 of 2 equals x. Example 3, log base 2 of 1/8 equals x. You can kind of see somewhat of a pattern. And example 4, log base 8 of 1/2 equals x. So I'm evaluating all these logarithms. You need to be able to do these without a calculator. I will show you some calculator hints eventually, but you need to be able to evaluate these for our no calculator quiz. So these problems, I'm going to use my backwards C method to convert them to exponential form. So in this first problem, I get 2 to the x equals 8. And that one's pretty easy to evaluate. I can think of this answer. I know 2 cubed is 8. If I didn't know that, I could start multiplying 2 by itself on the calculator until I get 8. So my answer for this one is x equals 3. That's the answer. That's because log base 2 of 8 is equal to 3. So now let's take a look at another case. In this case, when I do my backwards C, my 8 is my base to x equals 2. This is the case of when my base is equal to a smaller number. We discussed on the previous page, I might want to think of a fractional or a rational exponent. And in my head, I'm thinking, what root could I do for 8 to get 2? And I'm thinking I could do the cubed root of 8. So the cubed root is 1/3 as an exponent. So it looks like in this case, this is going to be 8 to the 1/3 power. So I know x equals 1/3 is my answer because log base 8 of 2 is equal to 1/3. So now let's take a look at this next problem. In this case, I get 2 to the x equals 1/8. So in this problem, this is an example when my base, which is an integer 2, is now equal to a fraction. When this happens, we want to probably think about how we can get that into the denominator. I mean, 2 to equal 8, 2 to the third is 8. I'm thinking about this in my head. But we want it in the denominator. So I'm going to think about 2 to the negative 3 because that would make it 1 over 2 to the positive 3. That would make my 8 in the denominator. So on this problem, it looks like my exponent, is negative 3. That is the answer. I would write that on the answer line. And I know that log base 2 of 1 over 8 is equal to negative 3. So now let's look at this last example I have for us. My base 8 to the power of x is equal to 1/2. So now this is an example of not only is the 2 smaller than my base of 8, but the 2 is in the denominator. So I need to probably put example 2 and 3 together to do this problem. I want to bring the 8 down to a 2, which I already figured out was the cubed root. And I want to put it in the denominator, which I already figured out is a negative exponent. It looks like my x is going to be a negative 1/3. Let me think about this down here. Let me just do a little bit of work. 8 to the 1/3 was 2. And I know 8 to the negative 1/3 would be 1 over that 2. That's 1 over the cubed root of 8, which is 1 over 2. So it looks like x equals negative 1/3 makes a lot of sense. And I know log base 8 of 1/2 equals negative 1/3. So those are some strange cases that come up sometimes that I need to think about without my calculator. I need to be able to do that. Let's look at some more cases that come up. So let me slide my paper up. I don't really know why that example didn't move with it. Now let's talk about when I don't see a base. So example 4, when you have a log and there is no base and you're supposed to evaluate it. So when there is no base, we are going to assume that the base is 10. So no base, you're going to assume the base is 10. So I'm going to write a 10 in here. So this is log base 10 of 100. I'm supposed to evaluate it. So remember, we're going to set it equal to x so that I can use my backwards C method to rewrite this as an exponential equation. And I'm going to look at this. I'm going to think of my answer and, I know that 10 squared is 10. So x must be 2. So the answer to this logarithm is 2. Let's take a look at this next problem. In this problem, log base 9 of 3 equals x. So again, actually let me take this x back. This is what this problem will look like. It will say evaluate. That will be the instructions. Like you were supposed to find that answer. It's asking you to find an exponent because that's what a logarithm is. So if the directions say to evaluate, you are trying to think of the exponent that is the answer. So the backward C is a way of helping me think of this mentally. I'm going to do my backward C. I'm trying to think of the exponent I raised the base of 9 to get the answer of 3. So again, this is one of those where my answer is less than my base. I'm probably looking for a fraction or a rational exponent. I know that the square root of 9 is 3. This is what I'm thinking in my head. In my head, I'm thinking, the square root of 9 is 3. So I know that my x then must be 1/2. My exponent must be 1/2. It must be the square root of 9 that I want. Okay, let's take a look at another example. In this example, log base 4 of 1024. So again, I'm being asked to evaluate it. So on your own, you're going to say, okay, I'm looking for the exponent, so equals x, backwards C. I'm looking for the exponent. I'm going to raise the base of 4 2 to get the answer of 1024. Again, you could just start by 4 to the first is 4, 4 squared is 16, 4 to the third is 64, 4 to the fourth is 256. 4 to the fifth power is the 1024. So I know that my x is 5 and that this logarithm is equal to 5. So now I've been talking about figuring it out without your calculators, like how do we evaluate these? But sometimes it's just not working. So let's take a look at that. Let me slide this up. And sometimes, I don't really know why up above. Let me see if I can slide it up some more. Just get it off the screen. Maybe I can do that. Okay, I don't know. So let's take a look at this next example, example 7. Log base 8 of 32 equals x. So when I do my backwards C, I get 8 to the x equals 32. And see, this isn't making sense right off the bat to me because I'm thinking if 8 to the first is 8, 8 squared is 64. Okay, so that's not it. I know 8 to the 1/3 is the cubed root of 8. It's 2. So I'm just a little confused about the 32. Like it's not working. You have two methods you could try. One method is to try what we call the same base method. So I'm going to rewrite these both sides with the same base. So I'm thinking about that 8 and the 32, and they are both multiples of 2. For example, I know that 2 cubed equals 8. So I know that 2 cubed equals 8. So 8 to the x is the same thing as 2 to the 3x. Let's pause and look at this for a moment. I'm thinking about 2 cubed being 8. That's why I wrote 2 cubed there, but it was already 8 to the x power. So when I now put the 3 up with my exponent, it's now the 3 times x. Now 32, I know is 2 to the 5th. 2 to the 5th equals 32. So I know that this is 2 to the 3x equals 2 to the 5th power. So if the bases are equal, let me get a different color. If the bases are equal, if the bases are the same thing, then the exponents must be equal. So I'm going to rewrite this as 3x equals 5. I know those two must be equal. So I'm going to divide both sides by 3, and I'm going to get x equals 5/3. So that means this is the answer to my problem. This means log base 8 of 32 equals 5/3. Let's check this, shall we? Because I'm just, what? So this means, let's check this. This means that 8 to the 5/3 must equal 32. What? Let's check it. So this means that I have the cubed root of 8 because I know the denominator is my root. And I'm going to try raising it to the 5th power to see if this is 32. So the cubed root of 8 is 2. And 2 to the 5th, oh, it does work out. 5/3 is the correct answer for this problem. Okay, let's try another one that's not super obvious. Example 8. So log base 36 of 216. So remember, if it says to evaluate it, you're going to add your own equal to x. That way you can do your backward C and rewrite this as 36 to the x power equals 216. Now, 36 squared is already a number much bigger than 216. So I know that's not the case. So let's take a moment to think about if there's any bases that I could rewrite this with. Well, 36 I know is 6 squared, and 216 is 6 cubed. I could probably do something with 6. So 36 is 6 squared, but I already had an exponent. So this is like 6 squared times this exponent of x. So it's 6 to the 2x. 2 times x is just 2x. Equals 6 cubed. So I'm going to set, because of what I learned before, if my bases are the same, I'm going to set my exponents equal. So in this case, I'm now going to set my 2x equal to 3, divide both sides by 2 and get x equals 3 halves. Let's say I want to check this answer. Okay, let's check this one. So I'm going to raise 36 to the 3 halves power to see if I get 216. So the denominator is my root, so it's the square root of 36 cubed. I'm going to see if that's 216. So the square root of 36 is 6, and then 6 cubed is 216. So it looks like these two problems check out. Thank you.